Welcome to your custom deep dive. You know that underlying sense of dread when you walk into a meeting room to give a
Oh,
presentation?
absolutely. The universal pre-meeting panic.
Right, you've got your laptop, you see this massive TV on the wall, and suddenly you're sweating, like fumbling with a rat's nest of adapters. You're just praying to the AV gods that your slides actually show up.
Yeah, we expect technology to just work, but the reality is usually an awkward silence and someone asking, is it on HDMI too?
Exactly. But then you walk into a modern boardroom or a massive sports bar with 50 screens, and it does just work flawlessly. So today, we're pulling from a stack of product specs from HDTV Supply to decode how this hidden routing hardware actually pulls that off.
Okay, let's unpack this. How do we go from the sweaty presenter to that totally seamless experience? Well, it starts with the invisible brain of the room. Looking at the specs for the Intelix AS-1H1DP auto switcher, this is basically a little box mounted under the table. It takes your standard HDMI or DisplayPort input and uses HD-based technology to send that uncompressed high-def video and audio up to 70 meters away.
Over a standard cable, right?
Yeah, over a standard solid-core Cat5e cable.
Ah, wait, hold on. I need to push back on that. HDMI carries gigabits of uncompressed data. And a standard Cat5e cable is, it's just a basic internet wire meant for checking emails. How is HD-T cramming all that pristine video through a tiny Ethernet wire without it looking like a pixelated mess?
It's a great question, actually. Unlike standard internet traffic, which breaks data down into packets that can arrive out of order, HD-based BT uses a unique modulation scheme.
Oh, okay.
So it essentially bundles video, audio, power, and control signals into one continuous high-bandwidth stream that's specifically designed not to drop a single frame.
Ah, so it's a dedicated pipeline. It's not just throwing data onto the busy office network. And you mentioned power. It powers the thing, too.
Yes, it uses POH, or Power over HDBaseT. It draws power straight through that Ethernet cable, meaning you don't need any clunky power bricks under the conference table.
That's super convenient.
It really is. Plus, it uses a laughed-in wins logic. You plug your laptop in, and it instantly detects the active video signal and switches inputs automatically. It even sends RS-232 commands to the TV to wake it up or put it to sleep after 30 minutes of inactivity.
Wow. So it's basically an ultra-polite digital butler. I mean, it sees you sit down, turns on the TV for you, handles the translation, and hits the lights when everyone leaves.
It's polite, sure, but from an IT perspective, it's really about self-preservation. It prevents users from breaking the equipment by blindly mashing buttons on the TV remote.
Right, just trying to find the right input. That makes total sense.
Hmm.
But solving the single room problem is one thing. What happens when you scale that up? Like, if I'm managing a massive sports bar with 20 screens, I can't have 20 independent digital butlers trying to guess what to do. I need a central brain.
Exactly. And that's where we get into something like the Wolfpack fixed HDMI matrix switchers. Now, people often confuse these with standard HDMI splitters.
Which are pretty basic, right?
Very basic. A splitter just takes one source, say a football game, and duplicates it to every single screen. But a matrix switcher lets you route any source to any screen, completely independently.
Okay, so a standard splitter is basically a megaphone, just one cable box shouting to a whole crowd of TVs. But a matrix switcher is more like a giant telephone switchboard operator. It's physically connecting caller A to listener B and caller C to listener D, all at the exact same time without crossing the streams.
That's a perfect way to visualize it.
Yeah.
Internally, the matrix has a high-speed backplane that manages those cross points without interference. The HDTV supply specs here specifically highlight their fixed configurations, like the 16 by 16 models.
Yeah, I was looking at those fixed models and they seem incredibly rigid. If a bar buys a 16 by 16 switcher and then next year they want to add 2 more TVs for the playoffs, are they just out of luck? Is that the catch versus the modular versions?
Yeah, that is precisely the catch. Modular switchers let you swap out cards to expand later. Fixed switchers, on the other hand, are entirely plug-and-play. They are highly cost-effective, but only if you are absolutely certain your input and output needs won't change.
Got it. But here's where it gets really interesting to me. How do you actually control a 16 by 16 switchboard without losing your mind? Because you certainly aren't juggling 16 remotes.
No, definitely not. And if we connect this to the bigger picture, this control aspect is what changes the entire dynamic of a commercial space. These matrix switchers integrate directly with third-party control systems like Crestron, for example, using TCP/IP or RS-232 hex commands.
Wait, let me translate that for a second. Those RS-232 hex commands, that's basically the raw machine code that lets the switcher talk directly to a custom software interface, right? Meaning A single bartender with an iPad can stand behind the counter, tap a screen, and perfectly orchestrate 16 different games across a massive venue, completely bypassing traditional remotes.
Precisely. It scales that automated IT control up to an industrial level.
So what does this all mean? It means the best technology is essentially invisible. The next time you walk into a flawlessly running boardroom or you sit down at a sports bar showing 8 different games, you'll know exactly how the hidden matrix is pulling the strings.
And it really raises a fascinating question for the future. As these central switchers and HD-based technologies become increasingly advanced at firing massive amounts of data over simple cables.
Will the physical screens of the future even need their own built-in intelligence or inputs? Or will they just become blank panes of glass, completely reliant on a hidden digital switchboard in a closet somewhere to tell them what to be? Now there's something to think about next time you're staring at a screen.